Hi, welcome to one and all. In continuation to my previous lecture, we have considered two examples for on the induced modulo and the extension of the Dirichlet character. We have a theorem. Theorem states that let chi be a Dirichlet character modulo of k and assume d divides k d greater than 0. Then the following two statements are equivalent. That is, D is an induced modulus for chi and there is a character psi modulo D such that chi of n is psi of n times chi 1 of n for all n where chi 1 is the principal character modulo k. So this is what we have to prove. That is, we have to prove that assuming D is an induced modulo for chi, we have to prove that there is a character psi modulo D such that chi of n is psi of n times chi 1 of n for all n. And assuming that there is a character psi modulo D such that chi of n is equal to psi of n times chi 1 of n for all n, we have to prove that D is an induced modulo for chi. So first we will prove from B, we will prove that if B is true, then we will prove that A is true. That is the first part. Later we will prove that if A is true, then B is also true. So first part is assuming that B holds. If B holds, then there is a character psi modulo D such that chi of n is can be written as psi of n times chi 1 of n for all n, where note that this chi 1 is a principal character modulo k. Now choose n. We will be choosing an n satisfying GCD of nk equal to 1 and n is common to 1 mod d. Then clearly you could see that this if n is constant to 1 mod and GCD of nk is 1, then we have this chi 1 of n. Chi 1 of n is 1 because GCD of nk is 1 means chi 1, the principal character chi 1 of n is 1. So that is true. So chi 1 of n is true 1. So if we substitute this is already holding, so we can substitute chi 1 of n is equal to 1 in this equation 17. We will get chi 1 of n is equal to psi of n. Chi of n is equal to psi of n. We will get that. What is the meaning of chi of n is equal to psi of n? It means that chi is an extension of psi. Means that chi is an extension of psi. So in that case we have already seen that D is an induced modulo for k. Induced modulo for k. So that we have proved that if chi of n, we have noted that chi of n is an extension of psi of n. So chi of n is already clearly 1 by our theorem, and hence D is an induced modulus. Thus we have proved that B implies A. Now we have to prove the converse part. That is, if D is an induced modulus for chi, we have to prove this condition. So that for proving this part, what we are going to do is we will prove this in 3 parts. That is, for terms we will be taking one case will be GCD of ND is greater than 1, then GCD of ND is equal to 1, and GCD of ND is less than 1. That is the 3 parts where we are going to prove. So now first assume that this A holds, that is D is an induced modulus for chi. Now we will exhibit a character psi modulo D for which this condition is satisfied. We define psi of n as follows. How to define this? If n GCD of ND is greater than 1, we will take, let psi of n is equal to 0. Then if psi of n is 0, in this case what we will have, we also have, since GCD of ND is greater than 1 means GCD of NK is also greater than 1. So if GCD of nk is greater than 1, then this Dirichlet character will be 0, because if GCD of nk is greater than 1, the GCD of a Dirichlet character is the chi of n will be 0. So in that case, this part is already 0 because I of n is 0 and chi of n is also 0. So both part is 0. So our condition 17 is satisfied. So 17 holds because both the members are 0. Now we will take the condition GCD of nd is 1. Then using the result, we have already studied the result that if n, k and d are given integers, the GCD of nd is equal to 1, then we can find an m. We can take an m is equal to n plus qd, where q is product of all possible primes which divides k but not n. Then m is congruent to n mod d and GCD of mk is equal to 1. This is the result. So by using this result, we already have GCD of nd is equal to, we have already assumed GCD of nd is equal to 1. So we can find an m such that there exists an integer m such that m is congruent to n mod d and GCD of mk is 1. These two things we got from this result. This can also be proved with some result using the Dirichlet theorem which you have studied. But I think this result, using this result will be more easy. So you can concentrate on this. No need to write this part. So here we have chosen an m also, which is unique modulo d. So we have chosen an m. So we can now define psi of n is equal to chi of m. For that m, we have psi of n is chi of m. Now clearly this psi of n is well defined because chi takes equal values at numbers which are counted modulo d. That is, chi of m is a periodic function. So it will be since this d is an since we have assumed that d is an induced modulo for chi, this chi will be repeating at each character each term content modulo d. So these terms will repeat at that time. So that term is well defined. Also chi is a character moduli that we have seen in the example also. So now we shall verify whether equation 17 is satisfied. For that, we already have assumed that nk is GCD of nd is 1. Also GCD of nk is equal to 1. This GCD of nd is equal to 1 we have assumed. So if GCD of nk is 1, then GCD of nd is 1. In that case, we have defined psi of n is chi of m for some m congruent to n mod d. So by using this, so this is nothing but we can use the previous theorem, that is 8.16. What is the theorem? The theorem is that this is some here, instead of in the previous theorem we have a and d and b and d, and a is equal to b mod d. In that case, we have n GCD of nd equal to 1 and GCD of md equal to 1. GCD of md equal to 1. So by using that theorem, what is that theorem in 8.16 is nothing but, if this condition is satisfied, then chi of a is chi of b. So same way here we have we can see that chi of n is same as chi of m, because instead of m, a and b, here we have n and m. So we have chi of n is equal to chi of m, but we have already defined what is chi of m. Chi of m is psi of n. Chi of m is psi of n. Chi of m is psi of n. So this psi of n times, we can write it as chi 1 of n, because when GCD of nk is 1, chi 1 of n is 1. Principal character, because chi 1 of n is a principal character. In that case, if GCD if nk is 1, then principal character chi 1 of n is 1. So in that case, we can write this psi of n can be written as psi of n times chi1 of n. So in this case also we have proved this condition 17. Now we have only left with one case, that is GCD of nk is greater than 1. In case of GCD of nk is greater than 1, then chi of n is clearly 0. Also this principal character chi1 of n is also 0. So both these two conditions, the chi of n is 0 and this chi1 of n is also 0. So in whatever be psi of n, we have both sides 0. So thus we have proved the result, and we have obtained the condition, that is in all cases or for all n we have chi of n is equal to psi of n times chi1 of n. That is, we can find there is a character psi modulo d such that chi of n is equal to psi of n times chi1 of n for all n. Thus we have proved the equivalence. Hope you have understood the concept very clearly. If you have any doubt, you can message me or call me. And thank you very much for your patient listening.